Hello, everyone. Welcome to this week's live stream. My name is Neil Kanungo. I am your host, and I'm joined. You want to say hi to everyone?
Hey, everyone. Thanks for joining.
Thanks for joining us again, Ryan. You've been doing some great presentations on chunking methods, RAG approaches. We had Michaela on to do evaluation of RAG approaches. We've had some really good content recently. For those of you that might have missed our sessions, you can check out the recordings on YouTube at KX Systems is the account name on YouTube. And I'll show that on the screen in a bit. But today, we're going to talk about using agents to maximize your LLMs. And Ryan has a great presentation today that we think will really help with the community on just educating about how agents work, how they can be used with different tools, how they can be used with RAG. There's lots of different topics we're going to cover. And so it's an educational session for us all to learn and share knowledge on agents with LLMs. Now, I wanted to let everyone know that if you have questions, you can put them in the chat. That's in the comment section on LinkedIn or YouTube, wherever you're viewing this from. And we will take those comments and those questions, and we will answer them live for you. So don't feel shy. Don't hesitate. We'd love to hear from you. Just put it right in those comment section. Now, let's get started. So before we dive right in, I want to talk a little bit about, first, this is our KX Systems YouTube channel. Just to let everyone know, that's the URL at the top. That's where you can find all our recordings. This session will be recorded, and it is being recorded as it's streamed live, actually. And so shortly after this session concludes, you'll be able to find it on YouTube as well. I wanted to talk a little bit about some of the struggles we see with RAG, and that is a lot of embedding models, a lot of different trunking strategies. There's different configurations for RAG results, scaling to thousands of documents. Our goal is to make RAG easier for you. Today's session doesn't focus exclusively on RAG, but we do want to make RAG easier, retrieval augmented generation, easier for you through education in the community and product enhancements with KDB.AI. So to let you know a little bit about who we are, KDB.AI is a vector database. It enables the most relevant temporal and semantic search to power language models and anomaly detection at scale. So we feel very proud of our scalability, our temporal features and benefits, our anomaly detection. If you're considering vector databases, I would consider KDB.AI. We are ranked #1 on dbengines.com, and we have the highest number of reviews and the highest rating on G2 as well. So lots of vector databases out there, but might as well try the top ranked one if you feel so inclined to. So some of the key benefits of KDB.AI are temporal language models, superior search mechanics, fast temporal embeddings, and scalable deployments. Just to let you know how you get signed up, this is just a little intro before we get started with the session here shortly. You go to kdb.ai in your browser. You can go to sign up at the top right, and you'll be presented with 3 different options. We have an Azure Marketplace offering with integrated OpenAI. We have a KDB.AI server, which is local deployment you can use for scalability. There's no limits on storage or memory. And then we have KDB.AI Cloud, which is my recommended way to get started easily. It's 4 gigs of memory, and it's an experimental place for you to just get started quickly. So that's on the left over here, KDB.AI Cloud. Sign up for free. When you sign up, you will get access to our Slack community, and our Slack community is a great place to ask more questions to people like Ryan and myself, and to others in our KDB.AI community and other experts at KX. So that's a little bit about who we are and how you can get going with vector databases and our community. With that, I wanted to go ahead and move on to our featured topic with Ryan, that's using agents to maximize LLMs. Ryan, you want to take it away?
All right. Yeah, absolutely. Sounds good. And thanks, Neil, for the introduction. And yeah, just a quick note on signing up for KDB AI. So you can do it very quickly, and there's an example notebook up there, and you could get an entire RAG pipeline set up and running using KDB AI as your vector database in a matter of minutes. So really cool stuff. Definitely check it out. But yeah, so today's topic is going to be on agents and discussing how we can use an agents to customize our large language models. So the agenda for the day, talking about what is an agent, why might we use them, talking about how can we use different tools and functions with our agents to really extend the capabilities of our large language models. And then we're going to be talking about several different types of agents as well. So LangChain has 4 different types of agents that we're going to be discussing here. And then also, how can we use an agent to assist us in doing retrieval augmented generation? So there's going to be a topic on that as well. Finally, we'll be getting into using Hugging Face transformers as tools for our agent. And then we'll talk about Autogen, which is a really interesting multi-agent framework. And then the last topic will be covering just a high level about OpenAI's new GPTs and Assistants APIs. All right, so let's get into it here. Agents. So why might we use agents? What is an agent? And it really starts with some of the limitations that large language models have. So currently, they're only able to answer questions about data that they've been trained on. So if there's recent events or recent news articles or academic articles that are released, a large language model is not going to be able to answer questions about that for you. It's not able to search the web on its own, and it wouldn't be able to respond about data that hasn't seen, like personal data or enterprise data. So it's not able to answer certain types of questions. And then other things like something as trivial as some math problems, it could actually hallucinate an answer instead of going through step by step and solving the answer. So there's some limitations that we need to keep in mind when we're working with large language models. And when we're doing our development, agents are one way that we could start to solve for some of these limitations. So what an agent is it is an LLM powered decision making engine. And its main purpose is to reason what steps need to be taken in order to solve a problem. So based on a user's query, it will decide what are the next best steps so that we can provide the best possible answer back to our user. And to do this, it really does it within 2 steps. It reasons and figures out what steps need to be taken, and then it will actually have access to certain tools, which are specialized functions to complete specific tasks. So a little diagram here about how agents and tools interact. So you have your large language model, and you can think of an agent in a sense as a wrapper around that large language model. And we know that our large language model, it has some limitations, like we're not able to do web search, and we may need a calculator for some more complex math problems. So the agent, we can give access to these specific tools that are really good at these certain tasks. So for example, there's web searching and calculators, different code executors you can use. You could do some SQL queries or other database types of queries, and then document searching. So these are some of the main types of tools you'll see out there that you can use with your agent to supplement your large language model. But you can also create custom tools as well. So one example we'll be going through momentarily is creating a custom retrieval augmented generation tool. So with that, let's talk about some of the LangChain agents that are available to us. So the first type of agent that LangChain has is called a zero-shot React agent. And what the heck does this mean? So we could just break this down. What does React mean? And this is really the type of agent that we're dealing with. So React means 2 things. Number 1, reason. Number 2, act. So it's able to take in a user's query, understand what that query is, and then reason about what steps need to be taken to answer this query, what tools need to be used to answer this query. And then it's able to act on that. So then it would be able to pass the relevant information and data to whatever tools it has access to in order to solve that problem. And then the zero shot part of this is a type of tool or a type of agent that is ideal for completing one-time tasks. So not really the agent you'd use in like a chat bot where you would really want conversational memory so it can look back upon previous conversations. But if you wanted to do like zero shot calculations, like with a calculator, for example, this would be a good type of agent to use. Now, even though it can't look back in conversation, it is within one interaction able to have multiple iterations with its tools. So maybe it can go out and get an intermediate answer from a calculator and then go back to it to get the final answer as well. So there is that possibility to have multiple iterations within a single interaction. And then here's just a little code snippet to show how you can set something like this up. So you would set up your large language model. Here we're just using OpenAI. And then LangChain actually has a math tool, which is a calculator tool that we can use. And all we would do here is instantiate that tool with the large language model and then load it as a tool here. Now, once we have this loaded as a tool, all we'd have to do is initialize our agent, give it that list of tools, which would just be the calculator tool we defined right here, give it the LLM, tell it what agent type we're using. So in this case, we're using the zero shot React description agent type. And then I would say one of the more important things you need to do is make sure you set this max iterations variable, because what we don't want to happen is just to get stuck in an infinite loop where the agent continues to go out to tools and continues to try to solve the problem. So that's a possibility. So you just want to set a max there. So we're preventing any infinite loops from happening. And then all you would do is just run that agent with whatever prompt you want. So in this case, we have a math problem that the agent would decide to send to the calculator tool to get an answer. So one thing to keep in mind with all this is with this type of setup, if the user asked a question that was not related to math, it's not going to be able to answer the question, and it will likely throw an error. So what could we do to create a bot that could answer more than one type of question? And in this case, we can do that by adding a few other types of tools to help us out. And these tools we would provide to the agent, so it's able to have a few different capabilities and not just the calculator capability.
And I wanted to add there, Ryan, just before we move on, if any of you have experimented with using LLMs with math, you've probably seen that LLMs do a great job at a lot of things, but math is not one of them. Right. It doesn't do basic arithmetic well. And so it's really interesting that you're showing here that you can extend the capability of LLM, Ryan, by adding a calculator function. I'd be interested, definitely in seeing how can I ask different questions of my LLM and have it automatically know, is this a math-related question? Is this not a math-related question? Which tool should I use? And how does it decide which tool to use?
Yeah, absolutely. And this slide should help to answer some of that question. So yeah, it's not necessarily going to always be getting math questions. So what other types of tools could we add? So in this case, just as an example, I'm adding a couple different tools that will help us out. So first of all, I'm adding a tool called SERP API. And this is a tool that is just a Google search. So it's able to reach out, API call to Google and get some information back. And then the second tool I'm adding is a custom tool that will simply pass our prompt directly to the large language model. So, it's a general query. We don't need to do a calculator. We don't need a Google search. Let's just ask the LLM and see what it says. So in order to do this, we have our initial math tool that we defined already up here, but let's add a couple more tools. So we're going to add that SERP API wrapper. So we just import that up here, and then you need an API key to use this one. But the goal here is we're just wrapping this search functionality into a tool. So in a sense, it's like a custom tool. We're creating a tool and giving it this custom search functionality that uses that Google search API. So all we would need to do is give it a name, give it that search function, and then a description. So we're saying this is useful for Google searches. And then we wrap that up in a tool, and in a list of tools just called Google Search. So that's the first one. And then let's say we want that second tool where we can call the LLM directly. We don't need a Google search. We don't need a calculator tool. Let's just use a large language model to answer whatever query we have. And in this case, we would set that up with a LangChain LLM chain. And all we're doing here is taking the user's query and we're passing that query in itself as the entire template. So in this case, what this chain is doing is saying, hey, here's our prompt. This is the query. And then you're passing it directly as is to the large language model. And that's the large language model chain. And again, all we're doing is defining a tool where we give it a name and a description, and we're just giving it this custom functionality right here, which would run that large language model chain and send our prompt to the large language model to then get an answer. And the description here is just, this is a tool for querying LLM for general queries and information. So now we just append all these to our tools list. So we already have the calculator one. We could throw in the LLM one in the Google search. And then when we initialize our agent, the agent will now have access to all of those different tools. So depending on the query, and it has access, the agent knows what these descriptions are, it can start to formulate the best steps in the process and which tools will be best to answer a specific question, whether it's a math tool or the Google tool or the just LLM general query tool. So like an example here, what is the longest river in the world? It might just go ahead and query the LLM, or it could decide to do a Google search, depending which one the agent thought would be better. All right, so let's get into a few other types of agents that LangChain offers, and depending on your use case, each of these agents, one could be better than the other. So this one's a conversational agent. It's still the React type of agent, so the reason and act. And this one is good for storing conversational memory. So it's able to have a chat history and then able to go ahead and look back at that to help it to answer questions. So it's really a similar kind of concept. You're just adding memory. And here's an example. So LangChain has a memory package we can use. Conversation buffer memory is that package. You just define it here. And the only real difference is we're changing the agent type, and then we are adding that memory in for the agent to use. So if you're building a chatbot and you want the agent to have access to memory and conversational history, this would be a great one to use. Okay, and third type of LangChain agent is called React docstore. So this one is good for searching external documents or document stores, an example of which is Wikipedia. And when you're using this type of agent, there's two key tools that you need to have. First is a search tool, and second is a lookup tool. So here, LangChain actually has a Wikipedia docstore that's already created for us. And what we will have is those two types of tools. So the search tool is used to go ahead and search the Wikipedia docstore to find the correct document. And then the lookup tool is used to find the relevant information within that document to pass to our large language model. So in essence, this is an example of RAG, where we're going out and we're retrieving relevant information from an external source, in this case, a Wikipedia docstore. So this is an example of how you can search a certain type of docstore to get specific information. Okay, and then the last type of LangChain agent.
There was a question by Adam here. This was related to a couple slides ago.
Sure.
When you're using multiple agents, will it query those agents sequentially in the order that you give it?
For multiple agents?
Yeah. Or yeah, when you're doing the Google search.
Oh yeah, for multiple tools. Yeah. So no, it will actually decide which tool to use. So it's not like it's going down sequentially. It has access to all of the tools that we have. So it would have access to the calculator, the Google search, and the LLM tool. And then when the user prompt is passed to the agent, that's the agent's job, is to decide which tool do I need to use to answer this prompt. So it may use one tool, it may use a variety of the tools. It's the agent's job to decide which tools to use.
Okay, great. And I just wanted to let folks know that I did put a link to our Slack community in the chat. So as you're watching this session, if you want to sign up for our Slack community where you can ask more questions after the session, feel free. Sorry to interrupt. Go ahead, Ryan.
No problem. Thanks for the question. So the last type of LangChain agent is called self-ask with search. And this is an agent that's specialized for using search to gain intermediate information when finding to assist in finding a final answer. So again, a good search tool we could use would be this SERP API, which is a Google search. And again, all we're doing here is just wrapping that Google search functionality into a tool and then giving our LLM access to that tool. The key difference here with this agent type is this is an agent type that's specially tuned to find intermediate answers. So it might be a multi-step type of a question where we need to do multiple Google searches in order to find the relevant information to bring it all together to be able to answer a more complex multi-tiered question. So this one's good for that intermediate information finding to assist in then finding the final answer. Okay, so the next topic we're going to dive into here is retrieval augmented generation and how an agent can help out with doing RAG. And I know Neil mentioned this at the beginning, but I've done a few different presentations that go through this in a lot more detail. So if you're interested in RAG in general and some different approaches, check out some of the previous presentations. But just a quick high-level overview. So retrieval augmented generation is giving your large language model the ability to answer questions about data that it hasn't seen and it hasn't been trained on. So like the example of internal enterprise data, a typical large language model is not going to be able to answer questions about that. So we can use RAG as a method to give the large language model the ability to answer questions on that unseen data. And the typical RAG pipeline is just taking your data, you take your data and then you chunk it up into smaller pieces. And we do that so we have more digestible and smaller pieces to feed into the large language model, which will make sure that everything fits in the context and the token limit of the large language model. And then we take those chunks, we create vector embeddings with an embedding model, and that's just taking our raw data, our raw text, and putting it into a numeric machine readable format that represents the meaning and the context of that piece of text in numbers in a machine readable format, and that's stored in a vector embedding is what it's called. And then we can use a vector database like KDB.AI, for example, to store all these vector embeddings in here. And because they're in this vector format, and KDB.AI offers several different really fast and efficient search capabilities, when the user queries, we actually embed that query the same way as we embedded our own data. And we can do then a similarity search or a semantic search between that user's query and then all of the vectors in the vector database. And the really cool thing about that is then we can in a very efficient and fast way find the most relevant chunks of data or the most relevant embeddings that are stored in that vector database, and then retrieve those and send those back to the large language model. So in essence, there's really two steps happening here. There's the retrieval step where we're retrieving our most relevant chunks of data, and then the generation step, which is where we're passing that to our large language model, and the large language model is then able to generate a response based on that relevant information. So that's just high level what RAG is, but we can use an agent to help us out with this. And an agent, like we've talked about, it's just a decision-making engine that tells us when what steps need to be taken to solve for a user's query, and it can decide what tools should be used to solve for a user's query. So what we can do is we can wrap up our retrieval pipeline in a custom tool and give our agent access to that tool. So then when we get a user query, the agent can say, depending on that user query, whether or not we should be able to, whether or not we should go ahead and run that RAG pipeline. So it's powerful because we don't always have to run it. The agent decides when we have to run it. And some more like naive RAG approaches, you're always running this RAG pipeline every time you get a user query. But with the agent, you don't always have to run it. So that gives it that extra layer of power and customizability. So just a quick bit of code on how you might set something like this up.
Sorry, just a quick question on that previous slide, Brian.
Sure.
When the user submits a query, does it go through an embedding model before it goes to the agent, or does it go directly to the agent?
So yeah, that's a good question. And my understanding is the agent takes in the user query as is. So I don't believe it's embedded right off the bat. When it would be embedded is when it goes through this retrieval pipeline.
Okay.
So that's when the embedding would happen. Yeah.
Thanks.
Okay, so the bit of code showing how we might be able to do this. And this is using KDB AI as our vector database. There's a couple steps before this to get this set up, but if you go on kdb.ai, there's a couple notebooks that'll show you. It's really easy to get this set up. But all this is our vector database, and it stores our relevant vectors. And our internal or enterprise documents all chunked up and embedded, and it's stored in this vector database. And then what we do is we define that RAG chain right here. And what we're saying here is that we are defining our large language model, and we're using that vector database as our retriever. So what this means is that we want to get the, say, top 10 most relevant chunks after that similarity search between the user query and kdb.ai. And so this step right here will do that, will perform that similarity search and get your top 10 most relevant chunks of data back. So this is your retrieval chain right here. And what we can do is just wrap that chain up inside of a tool. And we do this right here. So we have this whole tool defined as QA bot. And we just give it that custom functionality right here within the tool, give it a description, give it a name. And now we have a retrieval pipeline wrapped up in a tool. And then when we want to initialize our agent, literally we just pass in the tool that we just created. So now our agent has access to a RAG tool that it could go ahead and use to perform a RAG pipeline if it thinks it's necessary to do so. All right, so let's transition a little bit to some different types of agents. And this one, I find this one particularly interesting, to be honest. So this one is called Hugging Face Transformer Agents. And just a bit of a high-level overview of Hugging Face. So it's just an AI platform. It's an open source community where you can build and train and deploy and share different types of machine learning models. And the nice thing about Hugging Face is it has a ton of different transformers models available that are all specialized for their own different unique tasks. So you can find, and by the way, a transformer model is just it's a deep learning model. So we don't need to get too in depth on that, but it's a type of machine learning model. And these models, they have these specialized unique tasks. For example, you could use a transformer model to do image generation or image caption and question answering, image segmentation. And then on the document side of things, you can do question answering on documents, classification, summarization, sentiment analysis, I'm sure as well, translation, speech to text, and text to speech. So the point is, there's a ton of different models out there that do a ton of different things. And what if we thought about using each of these different models as tools for our agent to use? And this is exactly what the Hugging Face Transformer model agents can do. So the agent, it's an LLM in itself, and it decides which transformer tool to use based on that user's query. So let's take a look at some code to see how this might look. So we'll import our transformers, and what we're going to use here is OpenAI agent. So this is like a pre-built agent from OpenAI. You can also use Hugging Face has some open source agents we can use here as well. But this is the actual agent that we're defining. and we're just going to say, okay, use GPT-3 API key. And it's the beauty of this is it's really simple to do, and really in a couple of lines of code, you have a ton of power. So let's take this agent and let's give it a prompt. So generate an image of a cat in a boat on the water, for example. So in this case, what will happen is the agent will look at this query. It'll say, okay, I need to use the transformer model that will generate an image for me. So it will go out, it'll find the correct model, it'll then download that model and run the model all in one step. And then it will create this image of a cat in a boat on the water and store it in this variable. And this all happens, and including downloading the model, in a matter of a minute or two. And then after you have the model downloaded, like for future runs, it would even go faster than that. But all of a sudden, just in literally a couple lines of code, you have a full image generation capability at the tips of your fingers, ready to go. And then what you can do is you can pass this down and continue working with the same variable. So let's say, let's transform that image in the above picture to add a dog next to the cat. So in this case, we would just go ahead and pass in that previous variable, which holds this image, and the agent would see this and understand that, hey, I need to go get a transformer model that will augment an image for me. So it would then, again, download that transformer model and augment the image and store it in this variable. And you can keep on going with this. So you could say, okay, now caption the image, and it'll go ahead and go get a transformer model that's able to caption images and give you a caption. So this is all really easy to set up and use, and there's a ton of power and capability behind it. So really, really would recommend trying some of this stuff out and doing some experimentation with it. Okay, and the next topic is Autogen. So Autogen, it's a different type of agent framework, but it's specialized for building multi-agent frameworks. So it's Microsoft built, and this is like, I want to say this is within the last couple months this has been released, so it's pretty new. But it gives you the capability to actually create multiple agents and have those agents autonomously work together to solve a user's task. So when you define these different agents, and there's two key types of agents that I'll talk about here in a minute, but each agent will have a specialized role. And the power is that each agent has their specialized role, but they can also converse with each other and pass data and information to each other. And then you could have a group of two agents. You could have many different agents all working together that have specific tasks. And what's interesting is you could have these two agents working together, or a multitude of agents working together, but you can define how autonomous do I really want this to be. So you could say, I don't want any human feedback, and the agent would just work on their own. But you can also say, I do want human feedback, and it would ask you as the actual human in the loop for feedback every time there's a step taken. But anyways, how is this actually built? And there's two type of agents here. So the first one is a user proxy agent. That's what it's called. And it's represents the human in the loop. So it would be like you here talking to, ChatGPT or whatever, but it has some certain capabilities. For example, it's able to execute code, and it's able to give direction to other agents that it has access to. So you can kind of think about this one as like the manager. And then the second type of agent is called an assistant agent. And the assistant agent is where you would define like a specialty, like coding, for example. And what happens is these two agents work together to solve a task. And a bit of code on how this would be set up here. So first we define our assistant agent down here. We'll call it a coder. We give it a large language model configuration. And if you're interested in like diving into this, check out the documentation. There's all sorts of stuff you can configure in here. But pretty much this is just saying, this is a large language model I want you to use. And you can give it access to multiple different large language models too. In case one of them fails, then it'll go down to the next one and the next one. But so you get your assistant agent defined, and then let's define our user proxy agent. We'll give it a name. And this is where we can say, do we want a human feedback or not? And here I just say no, let it work autonomously. And I would say probably one of the most important things, again, is this iteration limit. So we don't want, we don't want this to go in some infinite loop, because it's going to take a long time and it's going to cost a lot of money. So let's make sure we cap that in case it gets stuck and it doesn't just keep trying. So we get that max iteration limit right here. We have a line right here just about when it should be terminating, so it understands when to stop the task. And then you can give it a working directory. So this is where the agent would be able to store files. It would be able to store, like, if you were asking it to create a Python script, it would store the script in this working directory. And then you also pass in that large language model config. So now we have both of our agents defined, and let's send them out to do a task. So here's the task: write Python code to output the first 20 numbers of the Fibonacci sequence. And all we do is we kick that off with our user proxy agent, and we give our user proxy agent, which is the manager, access to our assistant agent, and give it the task as well. So what would happen here is the user proxy agent would take this task. It would then say, okay, I need my coder to give me some code for this. So it would send it off to our assistant agent. The coder would then create some Python code to solve this problem. And once it does that, it passes it back to the user proxy agent. The user proxy agent then has the ability to execute code. So it'll execute that code. And if it's correct, it will go ahead and return that as the answer to the actual human user. But let's say there's an error. Then it will be able to pass that error back to the assistant agent and say, hey, this is the problem we're having. Here's the error message that I'm getting. Fix it. And the assistant agent will be able to amend its code or write some new code to fix that problem and then pass it back. And this iteration will just continue until either A, the answers or the question's actually correctly answered, or B, you hit that maximum iterations limit. So this is really the core of building a multi-agent framework. Now, there's a couple other types of things that Autogen offers, and one of them is a RAG agent. So it's a similar setup where you really have those two core types of agents. You have your user proxy agent, but in this case, it's called a retrieve user proxy agent. But what's interesting is all you have to do is give it a path to like the documents that you want to present to your large language model. So if you're thinking about that RAG pipeline, all you're doing is giving it a path to the documents that you want to perform retrieval on. And then it's able to, on its own, behind the scenes, download this data, chunk the data, embed those chunks, store it in a vector database. It does it with Chrome out of the box, but you can customize what vector store you use here. And it also perform the similarity search between the user's query and the vector database. So it's really powerful because you're just giving it the data and it does all this stuff on its own. And it does give you a decent amount of customizability as far as like choosing the chunk size and what embedding model you want to use and what vector database you would like to use as well. Now, if we think back to that two agent architecture, the second, which is the assistant agent, that one is the response generator. So we have our retriever, which gets the relevant information and chunks of data. And then we have our response generator, which is the generation side of things, where it passes this relevant information to a LLM and is able to get an answer based on A, the prompt, and B, that relevant contextual information that you get from the user proxy agent. So after it generates that answer, then it passes the answer back to the user proxy agent, and the user proxy agent would then evaluate, is this answer good enough to send back to the user as our final answer, or should we keep iterating on this to try to get an even better and better answer? So that's, I would say, the big benefit of this is its ability to do all this retrieval stuff under the hood, and then B, do some iteration to try to identify the best possible answer to give back to the user then. So that's how you can do RAG with Autogen. And this is a bit of code on how to set that up. So you define your assistant like we did similarly to above, and you define your user proxy agent here. Same sort of thing. Do we want human input? pass in our LLM config, maximum iterations. But here we can have a couple parameters to configure that under the hood retrieval. So here's the path to the documents. We can pick whatever embedding model we would want to use. You can pick your chunk size. So there's a number of things that you do have a bit of flexibility over as far as that retrieval process goes. And you could also choose your vector database here as well. And then, yeah, you just go ahead and send this off, give it a prompt, and it'll kick that process off and start doing that iteration, first with retrieval and then with generation, and go back and forth until it finally has an acceptable answer.
And Ryan, Christian Ramirez was asking if this Autogen RAG agent is from Microsoft as well.
That's correct. Yeah, it's all part of their Autogen package. So there's just the regular Autogen, which was the first example. They have then this RAG Autogen with these two other types of agents, which is the retriever assistant agent and then the retriever user proxy agent. And then they actually have another agent type that this one's like recently released, which is called a Teachable agent. So yeah, it's all from Microsoft. But anyways, the next type of agent is called a Teachable agent, and this one's sort of interesting because it's a little bit different than the other ones. But really, the goal for this type of agent is that it learns facts and user preferences and skills, and it stores all this stuff in a separate area, in a separate database. And the nice thing about this is that it's able to reference what it learns, not only during the current conversation, but also during subsequent conversations after that entire chat instance has been closed. So it's like a long-term memory for these different facts that it could learn. So like it could, learn the user's name, learn the user's birthday. How does the user prefer the answers be given? Like, does the user prefer it to be in a bullet point format, or does the user prefer more of a paragraph format? So it's able to understand some of these user preferences and then store these preferences in a database where it can access them later on. So good idea for if you're wanting to create a chatbot that you could use over a long span of time, and it's going to remember the facts that it learns along the way. Okay, and the final topic that I'll cover today is a bit about the recent release from OpenAI as far as their GPTs and their Assistants API. And what this is it's a way for you to use OpenAI to customize like ChatGPT. So I want to create a specific bot that does a specific thing, and the two different types are, like I said, GPTs and assistants. GPTs is like the kind of front end way to build one, a little bit more friendly, easier user interface. Assistants is more the back end API, maybe more designed for developers. But in essence, they're very similar, and they create a similar type of product in that hyper customized bots for certain use cases. So when you would be defining or creating one of these customized bots, there's a few different components that you give it, and this is going to relate to how this relates to agents in a minute here. But you would give it a role. So like, what do I want you to be? Like, is there a certain, like, do I want you to be a data scientist? Do I want you to be a CPA? Whatever. Do I want you to be Santa Claus? I just saw a GPT up there about specialized to be Santa Claus. Kind of interesting, but you give it a specific role, and then you tell it, hey, what model do I want you to use as far as the large language model goes? You can define whatever instructions you want, and you can get very specific here to really tailor your bot to a certain use case. But where this relates to agents a little bit more is you can give your GPT or your assistant access to certain tools. So you can give it the ability to have to perform web searches, for example. That's one thing you can do. But you can also give it access to tools like a code interpreter. So this would be where the code interpreter is able to write and run Python code It's able to process diverse files. It's able to generate files, and as well as generate images and also iterate to solve math problems and coding problems. So like there's a bunch of stuff that's packaged into this tool. But if you were doing some sort of a data science tool or a coding tool, this would be a perfect tool to add to your bot. You can also do a knowledge retrieval tool. So this is like OpenAI's version of doing RAG under the hood for you. You upload your files that you're interested in doing RAG on, and then it sort of takes care of everything under the hood. So you would be doing the data ingestion, the chunking, the embedding, the vector store, all under the hood in the similarity search. But it's kind of a cool thing because you're getting kicked off and you can just upload your files and it does it all for you. But from what we've seen from feedback from like doing these presentations and from the community, people are having some troubles with RAG and like what Neil said at the beginning, like it's sort of difficult to get highly accurate results. You have to do a good amount of tuning to really get the best retrieved results that you can from your database. So you want a good amount of flexibility in choosing your chunking sizes, choosing your embedding model. What large language model would work best for me? And having the ability to choose different aspects of similarity search and indexing in your vector store. And for example, KDB.AI has several different methods you can use to try to increase the efficiency of your similarity search and the different types of indexes you can use to speed up and create more accurate similarity searches. So just keep this in mind, though this is all under the hood or kind of one-stop shopping, there's a lack of flexibility here. And it's relatively expensive as well. So just be careful with how much data you'd be putting up on there because it's charged by amount of data. But it's one option that they offer as a tool. And then the final tool that they offer is a function calling tool. And this is pretty cool because what you do is you in natural text describe the functions that you would like the assistant to use, and then it's able to return those functions as well as return to you what are the arguments that you need to pass into that function. So just a high level overview of this. I mean, really, you could probably do a whole session on these GPTs and assistants, but they are, I would say, quite related to agents in some ways. And they have a good amount of customizability to a certain extent, though. So especially for RAG, be a little bit careful about how you're using this. All right, so I think that covers everything from my end. Really appreciate everybody joining in and asking your questions. And if there's any other questions, I'm happy to answer.
Yeah, so Arthi was asking, do you have any comment on the cost associated with using different types of agents? Like which agents are more computationally expensive than others? I imagine the first agent you showed was probably, with the calculator, just using a simple tool is probably the least costly. But once you start getting into the multi-tool agents,
yes, exactly. Yeah, the multi agents. I mean, they're because you have to think about it as an agents really themselves. They're using an LLM to determine the next steps. So when you're using an agent, it's doing an LLM call up front. So not only are you doing an LLM call to answer the question, you're doing an LLM call to understand the question first. So you're doing more LLM calls using an agent. And especially if you get a situation where you're going to be doing multiple calls, like iterative calls out to certain tools, every time you do that, it's costing a little bit more. So yeah, it can be expensive, and that's why it's so important to put that maximum iterations variable in there, so you don't accidentally get stuck in the infinite loop or a very long loop, and it's going to end up causing, number one, it'll take time, but number two, it's going to cost a lot of money. So you definitely want to be careful about that and be setting that maximum iterations.
Okay. And then Kushal had a question. Are you able to highlight certain fields of information using agents? Like, would it be able to recognize like personal and identifiable information and then highlight that as an agent, or is that a different approach?
That's a good question. I want to say there's likely tools that you could give an agent access to that would be able to tell you if information it might be PII. That would be my guess is the best way to approach that, and that may take a custom tool. You might have to write a custom tool to do that.
Okay. All right. Well, that wraps up for the questions today. I wanted to let everyone know that this session is recorded and it is on our YouTube at KX Systems. We have the previous sessions on here as well. So go ahead and visit and subscribe to KX Systems. And also to let you know that we have our Slack channel. I've mentioned this a couple times throughout the session. I put the link in the comments of LinkedIn. We'll put it in the comments in the description of the YouTube video as well. The link to join our Slack channel where you can ask other questions and get going with vector databases, agents, and LLMs. So with that, I just want to thank you all for joining again, and we will see you next time. We are doing a session on the 20th of December. It'll be the last one of the year. We're going to be showing Amazon Bedrock and KDB AI with LangChain. So we'll have Paula Clark on to show us that. Skipping next week, be back on the 20th. Thank you all for joining. Thank you, Ryan, for the great presentation.
Thank you. Thanks, everyone, for joining.